Welcome, senior engineers. For the past few years, we've been teaching large models how to talk, but the current paradigm shift is teaching them how to do. In today's guide, we are going to completely deconstruct how to build enterprise-grade core capabilities for Claude. Many engineers think writing an agent is just writing a long prompt and calling a few APIs. Wrong. If you run agents in production, you know that 90% of failures are due to context explosion and fragile integrations. Today, we're going to solve this problem once and for all with a standardized engineering approach. There are currently two standardized scaling solutions that have been proven in the industry. Agent skills are file-based portable knowledge packages, like recipes for a master chef. The Model Context Protocol, or MCP, is a real-time system integration protocol, equivalent to outfitting the chef with a kitchen. They aren't competitors, they are perfect complements. Let's start with high-level core definitions to clarify the boundaries and nature of these two architectures. On the left, we have agent skills. These are plug-and-play file packages, extremely lightweight and stateless. On the right is MCP, an open-source protocol by Anthropic. You can think of it as a Type-C port for AI. One teaches the AI the steps. The other plugs the AI into databases and local tools. As architects, we need to look at trade-offs. The integration cost for skills is incredibly low. Just drop them in a directory and run. They are perfect for SOPs and templates. MCP, on the other hand, runs on the JSON RPC 2.0 protocol and is ideal for dynamic data sources that require maintaining a connection state. Don't use a cannon to kill a mosquito, and don't use a paper knife to cut a steak. Next, let's dive into the technical architecture of agent skills. We'll see how it solves the most fatal issue in large agent projects, the context window problem. Imagine you give Claude 50 enterprise-grade skills. If you stuff all the documentation into the system prompt, even if the context window can hold it, it triggers the lost in the middle effect. The model gets dumber. So, the underlying architecture uses a very clever mechanism, progressive disclosure. This is a 3-tier loading architecture. Level 1 only loads the names and descriptions in YAML, taking up about 100 tokens. Only if Claude reads the description and thinks it's useful will it proceed to level 2 to load the full markdown instructions. If code is needed during execution, it enters level 3 to pull scripts on demand. This on-demand loading perfectly protects the context window. Let's test everyone. A skill with a 10 MB PDF, how many tokens does it cost at startup? The answer is C. Startup only incurs a metadata overhead of a few dozen tokens. If you got this wrong, it means you haven't yet gotten used to this on-demand mounting mindset. So, at the file system level, what exactly does a skill look like? Let's take a look at the topological structure at the code level. This is a standard skill directory. There's only one core component, skill alta MIDI. The other scripts, references, and assets are optional. You can package it all into a zip file, toss it to anyone, and their Claude will instantly master this skill. This is the source of its extreme portability. This is the YAML at the very top of skill MD. The name must use kebab case, and the description must explicitly state when to use. Here's a massive pitfall. Never write XML angle brackets in the YAML, because Claude's underlying layer heavily uses XML tags to isolate context. Your angle brackets will be treated as a prompt injection attack, directly causing the skill to fail to load. Now that we know the structure, let's look at the standardized workflow for a developer building a complete skill. The development process is actually very simple, a 5-step approach. The hardest part isn't writing the code, but the first step, defining the boundaries. Don't write a skill that solves all backend problems. That's a wishing well. What you should write is a micro skill that parses Postgres slow query logs, maintain absolute atomicity. Now that we've covered file-based skills, let's do a hardcore breakdown of the protocol-based MCP. This is the key to truly connecting your agent to everything. MCP has huge ambitions. It wants to be the USB-C of the AI world. Previously, we wrote one plugin to integrate Jira and another for GitHub. Now we don't need two. MCP abstracts three core primitives. Tools are functions that can change system states, resources are read only data sources, and prompts are templates. Unified interfaces connect once, run anywhere. Look at this architecture. The host is the host application, like Claude Desktop. The client handles maintaining the connection and serialization. The one doing the actual work is the MCP server. They communicate via JSON RPC 2.0. This decoupled design means your server can be a local script written in Python or a remote enterprise intranet microservice. Here is a pitfall that senior engineers easily fall into. If you run a local MCP server using Studio, JSON is transmitted under the hood via standard input and output. If you habitually write a print statement in your code to log something, congratulations, that string will get mixed into the JSON stream and instantly crash the protocol parsing. Remember, all logs must go through Sterde. Let's quickly test your architectural intuition. What do you use to read an intranet release status that changes every minute? The answer is B, MCP. If you use skills, would you really update the markdown file every minute? Remember, use skills for static knowledge, use MCP for dynamic states. Now that the theory is out of the way, let's see how these two combine in an actual production environment to form an autonomous agentic loop. In a production-grade application, an agent is not a one-off conversation, it's a loop. When the model encounters a problem, it decides to call a tool and stops generating. At this point, the stop reason is tool use. The host executes your MCP tool, stops the result back into the context, and the model continues thinking. Once the task is finished, it throws end turn. This is where autonomy comes from. When tasks are extremely complex, we need a multi-agent architecture. At the center is a coordinator. It doesn't do the work itself. It spins up sub-agents by calling a task tool. Sub-agent 1 might bring a specific skill to write code, while sub-agent 2 might connect to MCP to query a database. Note that the sub-agent's contexts are isolated, so the coordinator must explicitly pass along any necessary information. After falling into countless pitfalls, we've summarized the following best practices for enterprise-grade development. First, maintain 100% atomicity, build micro skills, not grand narratives. Second, never hardcode passwords or tokens in Markdown. Use environment variables or MCP injections. Third, the one-sentence test. If you can't clearly write in YAML exactly when it should be triggered in a single sentence, the skill is designed too complexly and must be broken down. Look at this comparison. The bad description says deals with Git commands and repository stuff. This will cause Claude to load it for any mildly related topic, wasting tons of tokens. The good description adds strict limiters like only when and clearly specifies which scripts it will call. Precise triggers are the cornerstone of an excellent agent. On the MCP server side, thanks to modern SDKs, exposing a tool is incredibly simple. You just need to write a standard Python function, add strong type annotations and a docstring, and attach a decorator. The SDK will automatically convert your comments and types into a JSON schema and feed it to the large model. Code as documentation. Extremely elegant. Let's do a quick recap of today's high-frequency terms. Progressive disclosure protects the context. JSON RPC is the lifeblood of MCP. Stop reason is the engine of the agent loop. Task tool is the heart of multi-agent architecture. Studio is the local communication trap. And micro skills are our ultimate design philosophy. I recommend taking a screenshot. If you only take away one sentence today, I want it to be this. Don't make it a single choice question. Top tier architects play in hybrid mode. Use skills to teach Claude your company's code conventions and business SOPs, and use MCP to plug it into your Jira and GitLab. Knowledge belongs to knowledge. Action belongs to action. So what's next? Don't go refactoring your entire system. Find the 3 pain points your team repeats every single day. Write 3 simple skill MD files for them, run them, and watch how Claude calls them autonomously. Go get your hands dirty. Welcome to the era of autonomous agents. See you next time.